Hi everyone, hope you are doing fine. So today I am going to solve the uh, daily challenge problem of the lead code. So the problem name is find the safest path in a grid. So in this problem, we have given a grid of n cross n. Yeah. So you can see we have a grid of length of n cross n, and this cell can contain either a thief if the value of grid is like 1, and the n cell is empty if the value is 0. And initially we are at 0 0 position, and in one move we can move to any adjacent cell like if we at 0 0 we can move left, right, up and down. And the safeness factor of a path on a grid is defined as the minimum Manhattan distance from any cell in path to the any thief in a grid. And we have to reach the n minus 1 and n minus 1 cell, and we have to run the maximum safeness factor of all the path leading what is the best possible uh, answer to reach n minus 1 and minus 1 cell from 0 0. So yeah, so there is a formula how to calculate the distance between two cells. So it is simply a like absolute of position x position and the y position. So yeah, let's see how we can solve this problem. So let's take this problem, this example, and try to solve this. So yeah, so we have something like a 2D matrix like this, and let's say we have to reach this cell, like this is the cell n minus 1 comma n minus 1, and this is the cell 0 comma 0, 0 comma 0. So let's say this has one value, that is thief, and all the other value has 0. So now as the other value are 0, so we have to find the a valid path, like a path to reach n minus 1 n minus 1, that is the last cell of this grid, like this cell, with the maximum safeness value. And the maximum safeness value is defined as like if we are taking this path like this, then what is the minimum distance from any thief to this path, this path cell. Like in this case you can see this is the closest cell to this thief cell. So what is the distance between them? So yeah, so we have to maximize this distance. So first approach is that what we can do, we can simply generate all the path, we can generate all the path. Let's say this one path, like this one, like every path, with the help of recursion we can generate this all the path. And then after generating the path, while calculating the path, we also maintain a list of all the indices, like ij indices, where the value of that cell is 1. So let's say we are calculating for this path, so we can check for every cell where the value is 1, we will try to calculate the distance, like what is the minimum distance. And whenever we do for this, firstly we do for this, then we for this, then this cell, then this cell, again for this cell, and this cell, and this cell. After that we are going to take the minimum of all these things. Whenever we have take minimum of all these things, because we have to find the maximum safeness. So yeah, so after doing this path we get something like value. And from every path we are going to take the maximum, like while calculating for us the Manhattan distance in a single path, we will take the minimum, and overall we will take the maximum of all the path. So yeah, so we can solve using this approach. But as the constraint of problem is quite high, like it's a 400, so it will be it will not pass this pass all the test cases. So we have to come up with some optimal approach. So let's see how we can do. So first thing is like we what we are doing, we are checking for every time, like if we are like if we are sell this, we have to check for every other cell which has value 1, what is the minimum distance, like minimum distance to the thief cell. So instead of doing that, what we can do, like let's say we have something like this, so we can simply pre-compute the value, like what are the like what are the what is the minimum value to reach this path, like this cell and this cell, like for every cell we can calculate. So how we can calculate? So for this one approach is that we can take this, simply take all this value, like the where the value is the one, and then try to loop this thing, like then fit and like start from like first this because this come first if we iterate the loop, and then again we will do again we will again loop this thing, and then we'll try to compute for like this cell, this cell, this cell, this cell, like whole this cell. Then again for this cell also we can do same thing. But if we do by this thing, like the time complexity is going to be n raised to power 4. So like because like firstly we have to loop do two loop to iterate this thing whole matrix, and then again two for calculating the minimum, like minimum distance, so it will go like it is quite high. So another approach is like it is a very common approach and it is used in many more problems like this. So what we can do, we can do a DFS from every, like we can start a DFS from all the from all the value, like all this cell where the value is 1. So let's say like this is the first one and this is the second one, then we move to its current cell, like it's all the adjacent cell, like this, like 1 2, like these are the one, like this is not just because we can move only left right up and down, like this. Not we can move something like this diagonally, it is not given in this problem. So yeah, so we move this one, so we can reach this in one and this in one also, like we can simply calculate the distance. For now I am simply marking distance as the like what is like position, like in this we reach in one and this in one. Then again to the from here we can reach it in distance, like we can say 2. And similarly for here it is going to be 1 1, and then from here 1 it is going to be 2, it is also going to be 2, it is also going to be a 2. And similarly we can calculate this for like whole of the matrix. And after doing that, now we have do this thing. Then again first approach, like we can calculate something like a path, but like generate all the path, or we can say we can use something like yeah, we can use BFS to find the one of the optimal path. But again it is going to be a like in the worst case it is going to take a lot of time because we have to generate all the possible path. So instead of doing this, what we can do, like because now we have generating the like what is the minimum for every, like minimum for every cell to reach this to reach the thief from this cell, what is the minimum time. So instead of doing this, what we can do, we can simply do a binary search, like let's say we are calculating for k equal to 5. So we 5, so we can check like I can we move from this cell to this cell. Let's say like if this value is 1, we can move to this cell. From 1 can we move to this cell? Yes, 2, because this value is k is 5. So we are checking like whether k can be our answer. So it means that for every cell the value mean value must be less than or equal to k. Again this value is like less than 1. Like if let's say this value is 6, then we can't move to this, then we have to take another, like we can move to this cell, like by doing this. So in this case we have to iterate only like n cross n cell in worst case also. so it is going to be an n square. And for a binary search is going to be a big of log n, and we can say like it's a 400 cross 400, 400 cross 400 matrix. So let's assume that it can be up to like 10 raised to power 16, Manhattan distance between two can be a max of this, like it is going to very less than 10 raised to power 6, but we can assume it is 10 raised to power 6. But the log of, and like we have to do only binary search on this 10 raised to power 6, so log 2 of 10 raised to power 6 is going to be very less, like I think around 20 or 18. So yeah, so it is going to be a 400 cross, time complexity is going to be 400 cross 400 cross we can say like 20. So it is going to be like we can say 4 4 16, like 10 to the power 5 and 6, like we can say 10 to the power 7, like which can be easily passed in 1 second. So yeah, so let's try to write the code for this. Let me copy this. So yeah, so let me firstly input the 2D vector, which is of sign n, and also like it is a n cross n, so it will look something like this. So yeah, let me input this thing. So we are getting the answer from here. So answer is the solution, sorry, s dot maximum say safeness factor, and we have to pass simply a v here. So yeah, so let's say int n equal to, like we are taking the size of this, then firstly we have to iterate the whole array. We have to take q of pair of int comma int, and we are going to uh, iterate this whole matrix, and like if v of I comma j is equal to 1, then we have to add it into our queue. So we are simply adding this into our queue, like yeah, I comma j, and after that we are doing this like until the our queue become empty. So yeah, so now we have to simply do our iterate our queue, and now we have to move it in our four, like all the four direction, like k equal to 0, k less than 4, and k plus plus. So like there is a like very easy way to iterate in our four direction. So in this we are going to we are going to create two array, like with 0 0 1 and -1 value, and in the array 2 we are just reversing the array, like 1 -1 0 0. So by doing this we can iterate in our like a four direction, like int x is going to be a plus array 1 of k, and int y is going to be b plus array 2 of k, and a is going to be a q dot front dot first, and int b is going to be q dot front dot second. So yeah, and we are going to pop out this thing, and we are also going to maintain a like a dp, like what is the minimum time, like a minimum value to reach a minimum distance between and the cell and the thief cell. So for that the distance between a thief cell and thief cell to thief cell is going to be a 0. So yeah, that's why we are declaring it above, and now we are simply making it as a like a minimum value initially. and we are going to make v of I comma j is to equal to 0. Yeah, so that's it. And now we are going to check like if the like if this cell is in a matrix range or not, if x equal to 0 and y equal to 0 and x less and y also less than n. And also check yeah, this thing. So now we check if the distance, but like so formula for distance is like absolute of a minus x and absolute of b minus y. So yeah, so we can check if the distance is greater than equal to our dp value of x comma y, like a data like oh so sorry. So as we have to make it minimum as possible, so we are making it as a int max. Yeah. So now we have to check if the distance is greater than if it is a greater than dp of I value, then we have oh sorry it less than this. So we are updating dp of x comma y to a distance. So by doing this, we are generating our so it is so yeah. So by doing this, we are generating this thing, and now we have to do a bind search. So yeah, so it's a simple way to do a bind search, and so we can simply check while low less than equal to high and int mid equal to low plus high minus low divided by 2. And we will check like we will create a function like name is possible, like if it is possible for this value which take vector v dp and mid value. Yeah, so if it is a true, then it mean we can increase our value. So we will increase our low to mid plus 1. So now check for a next range, because like if it is possible for low, now there is no need to check for a value less than low, because for that it is always going to be a true. So then we are going to make a high as mid minus 1 if it is false for that thing. So we are going to decrease the value. So yeah, at the last we are going to return a high. Yeah. So now we have to write function bool is possible. So firstly it is going to take a vector, then it is going to again take a vector of dp, and then it is going to take a mid, and let's say we are calling it as a k. So yeah, so n equal to v dot size. So how we can so to calculate this, so firstly we have to make something like a maintain a visited array, so which will tell like whether we have already visited, because it's a like we can move in a four direction. So there is a possibility that we can again come to same thing again and again. So if we have something like this, like if we are currently at uh, this value, if we move to right, then again move down, then move left, and then again move right up. So we can see that we in a we in an infinite loop, we can run in an infinite loop. So we are checking like we are marking it is as a false, like if it is a false we can't move here further, like so yeah. So to track this thing, I am maintaining this visited array which is of n cross n, and initially all the value are true, or we can say like all the value are false. If it is a false, then we then only we can iterate to this. So yeah, so we can check like if v of 0 comma 0 is like if the first value is less than k, it means that it is not possible. And similarly we can check for n minus 1 and n minus 1 value. If it is for it is less than k, then it means that it is not possible to get this answer. So we are simply returning false. Then we are going to create a queue which is of pair int combined. Yeah, and we are going to add something like 0 comma 0 to that, and we do like while not of priority like queue become empty until queue become empty, int a equal to queue dot front dot first and b is going to queue dot front dot second. We are going to pop out this thing, and then we are moving in all the four direction. K equal to 0, k less than 4, k plus plus. Int x is going to be a plus array 1 of k, and y is going to become the b plus array 1 array 2 of k. So if x is greater than equal to 0 and y is greater than equal to 0 and x less than n and y less than n, and also like a visited of uh, x comma y is equal to false, and also we have to check like a dp of x comma y must be greater than or equal to k. In that case we can simply q dot push x comma y and also mark this as visited, because now we have visited this, so we can't again traverse this thing. And also we have to make vis of 0 comma 0 to true, because we already visited this thing. And at last we are going to return, we can say like we can return false, and we can check if a equal to n minus 1 and b is equal to n minus 1, like we can reach last cell, then we are going to return true. I think this is more like this is more than enough for this thing. So yeah, so let's try to compile this code. So we are getting this error. So where are I am using size. So yeah, I have not declared size equal to q dot size. Again we are not getting answer. So let's try to print this dp thing for auto a comma it cout a. So all the values, oh sorry, yeah, we are taking and then we are taking v of I comma j. Yeah, this thing is correct. Then why this is not working, like uh sorry, it is going to be a dp of I comma j. So it's going to be dp of I comma j and distance. Why it is not working? What is distance for this? Distance is 1 comma 1. So yeah, it is working, but we have to also like push this thing in queue, because we have to move to next iteration also. Yeah, So yeah, so we think miss the one thing, like as we are doing like so let's take this like this is 0 0 0 0 1 1 2 1 1 1 0 2 2 2 3 2 4 and 2 5. So like from 0 4 to like this one step, you can see that the Manhattan distance is going to 1 1 for this. So like if we calculate for this two distance, it is going to be a 2. Then again for like this 1 and this 2, you can see like for this it is also going to be a 2, and then for this it is going to be 3, then also for like 3 for this it is going to be 3. So uh to do this thing, so instead of doing this so we are going to make something like a count equal, we can say like a initially the count value is, we can say, the 1, and we are assigning this value to like a, like if the count is less than dp of j ij, so we are assigning this as a count. So yeah, so after every iteration we are going to increase the value of count. So now let's try to, yeah, now I think we are getting right thing. So yeah, so let's try to print the answer. So in this we are getting 0 as an answer. I think in this case the 2 is going to be answer, because if we take path like 2 3 4 3 2, so 2 is the answer in this case. So like is this is possible, is working correct or not? So we are doing something like, so let's print forward value, it is getting answer. Wait, does it run for 2? Yeah, it run for 2, but for 2 it is getting false. So let's print a b. So it is going to be a dp, not v value, because we have to check for dp thing. Yeah, so now it's working fine. So let's try to submit this out. So I think it should work. We are getting wrong answer for this. 3333. I think 2 is the answer for this. Output 3 expected 2. So let's try to run this thing also. For medical to 3, how it is even possible? So we are at 0 0, from 0 0 we move to 0 1. But how we can move from 0 0 to 0 1? x y comma dp of x comma y. So what is value of k? How the value of k is decreasing? Oh no. So I think we have to make this as a capital K because I am using same variable name k and k. I think now it should work. So yeah, I think this is the mistake. So let's try to submit this thing. Yeah, now it's working. So let's move the console from this, all the console statement. Yeah, I think again I have uh, printing the whole. Yeah, now I think it should work fine. And let's try to submit this thing. So yeah, so that's it for today. So the time is like, so it is quite late. So yeah, so I saw try to solve this problem like the third problem, like third problem of the contest I solved yesterday. So but like I was able to solve it with like a n cube approach, but like that will not but again that will it give me a TLE. So I like try to optimize this thing, optimize the code, and I think I spent around like 2 to 3 hours on this problem, but I again not get this solution for that. So yeah, so this is the solution I get. So like this is the same approach that I was thinking yesterday. So yeah, I implement this and try to dry run a lot of example. So yeah, so it works, but it's give TLE. So I again try to optimize and read some solutions. So yeah, so you can also read some solution like this is a like this is a similar kind of solution to this, but it has some optimization in this I am calculating again like this loop is the optimization in this. So yeah, so I try to understand it, but I don't get the solution, and I also like ask ChatGPT to explain this explain this code. Like I simply ask ChatGPT, can you optimize this code? So how can I optimize this code to do it in a big of n scale? So it gives pretty like a I can say like 90% of code is similar to the this approach. So yeah, but I don't understand. Like I try firstly I try to dry run that code. Yeah, then I think that yeah, it's easy. Then I try to code that solution, but that don't work. So yeah, I think that today like I will try to solve that problem today, like after the office work. So yeah, so let's see. If I was able to solve, I will tell you in tomorrow video. So yeah, that's it for the today. Thanks for watching the video.